For this vodcast, please have note pages 4 and 5 in front of you. Two topics of discussion for this vodcast are going to be properties of organic compounds and different types of chemical formulas, specifically for organic compounds as well. Okay, properties first. As you can see that there are many different properties here, I would suggest, once again, making some flashcards here, putting the definition on one side of the card and having the term on the other side, because these are 5 very important pieces of information that we're going to be referring back to during the course of this organic chemistry unit. All right, as far as bonding goes, we kind of talked about this already. The bonding type is going to be covalent or molecular types of bonds. And we should know by now that whenever you're dealing with a covalent or a molecular bond, you're dealing with 2 nonmetals, always. You will never, ever see any metals incorporated within an organic compound. Now, the solubility, most of them are insoluble in water. Generally would make them non-polar. All right. In other words, like will dissolve like. All right. We've seen this expression in past units as well. All right. So keep that in mind. If we're dealing with these insoluble organic compounds, we're talking about polar and some sort of inorganic compound, specifically hydrocarbons. All right. Conductivity, mostly non-conductors. All right, they do not produce electricity for solids, liquids, and aqueous states. Only organic acids ionize. All right, they produce ions in solution. Yes, they do conduct electricity, these organic acids, but it's a very poor conductor. All right, it will conduct, but it'll be very, very poor. Melting boiling points. Very weak intermolecular forces. Therefore, they have low melting points and boiling points. So in other words, they're going to melt and boil very easily. Reactivity rates, how fast they react. These organic compounds, they react slowly. Covalent molecules tend to have relatively high number of bonds, meaning that there are many more steps necessary for these bonds to be broken in order for the chemical reaction to go to completion. Therefore, the reaction takes much longer to complete. All right, so just a few properties there to keep in mind. Now, the different types of chemical formulas that we're dealing with. You can see that there are 3 of them: molecular, structural, and condensed. Let's talk about molecular first. Molecular formula, what it does is it shows the number of atoms of each element in a compound. This is the least informative formula. All right? It's less bulky, no doubt about that, but it doesn't provide a ton of information. All right, an example would be propane gas. Within the formula propane gas, it tells you that there are 3 carbon atoms and 8 hydrogen atoms. All right, so that's the molecular formula. Now for the structural formula, it shows also the number of atoms of each element, and, this is an added bonus, the arrangement of the atoms. This is considered to be the most informative formula. Here's that same compound, that same organic compound of propane. All right, you can see that we've got our 1, 2, 3 carbon atoms. Here are the 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms, which gives us the formula C3H8. Okay, this is the bulkiest. All right, so that's certainly a negative aspect. Here's your positive aspect right there. Okay, now the condensed formula, this is pretty much a combination of both the structural and molecular. Formulas. Each carbon is written with the constituent hydrogens followed by the proper subscript. Let me go back up to the structural formula. Let me show you something here. If you take a look at this first carbon atom right here and the hydrogens that are attached to it, that's the first portion. Let's take a look at the middle portion right here. Here's your carbon and your 2 hydrogen atoms attached to that. And then finally, here's our third portion. Okay. Now, with that said, if we take a look at the condensed formula, this CH3 right here represents what's in green up here. All right. The CH2 represents what's in yellow up here. There's your carbon and your 2 hydrogens. And then finally, the CH3 represents what you see here in blue. Here's your carbon and your 3 hydrogen atoms. All right, you're going to be expected to know how to write out all 3 of these types of chemical formulas, and then maybe over the course of time, you'll probably pick out a favorite of the 3. All right, let's go ahead and proceed to page number 5. Let's do some open-chained aliphatic and closed-chain aromatic problems. All right, we're going to use both the formula and the condensed, the molecular and the condensed formulas in order to illustrate how these chains are actually put together. All right, if we're looking at the molecular formula first, what you want to do is count up number of carbon atoms, 4, 5, 6. So we have C6. And then you're going to go ahead and count up the number of hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we'll finish our chemical formula. We have C6H14. Now the condensed formula of this is going to be, here's our first piece to the puzzle. All right, so we're going to write out CH3. Second piece, right here. We're going to attach a CH2 to this. Next piece, another CH2 is going to get attached. A third CH2. A fourth CH2. And finally, the end of our organic compound, CH3. Okay, so there's your chemical formula for molecular formula and the condensed formula. All right, now next one. Let's take a look at what we have here. Molecular formula, count up the number of carbons that are present, C4, number of hydrogens that are present, H10. All right, let's take a look at the condensed formula. We have CH3 to start with. We have CH2 next. We also have another CH2. And finally, to conclude, there's our CH3. It's going to go at the very end of the condensed form. All right, now the next one is a little bit trickier because of the double bond that's found right in the center. Let's try this one together. Now the molecular formula, you're going to count up your number of carbons. We have 6, just like in the first problem. However, in the first problem, we had 14 hydrogens. This time, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And the reason we have a different amount of hydrogens is because of that pesky double bond right there. All right? So the chemical formula is C6H12. Now let's come up with the condensed formula. All right, here we go. Start off with a CH3. Next up, CH2. All right, this is where it's a little bit different from what we've seen. There's just a plain CH. Next, we have another CH. Back to our string of CH2. And finally, we're going to conclude with a CH3. CH3 at the end. Right? So each formula represents the same thing, but we're looking at the molecular and condensed formulas. These are for open chain aliphatics, right? There's no closure to this. Now, if we take a look at the bottom where it says closed chained, these are called aromatics. These are the ones that usually put off some sort of scent, an odor like peppermints or spearmints. All right, let's take a look at this one. All right, same thing with the molecular formula that we did up above, right? In looking at this ring. All right, there's no condensed formula for this one, just the molecular formula, okay? All right, so same deal. Count up the number of carbons. 6 of them. 6 carbons. Take care of the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each 12. All right, as you can see, each carbon has 1, 2, 3, 4 bonds. That's important when you're drawing out these rings, aromatics. Now, when drawing organic compounds, you must always have the 8 electrons around each atom. Right? We've got the 4 pair here, which equates 8 electrons. Right? So that's perfect. Exception to the rule are going to be hydrogen. They achieve their octet when they have 2 electrons around them. Okay? So to conclude, we've talked about the properties of organic compounds, the different types of chemical formulas, and you saw the 2 different types in action here in dealing with the open-chained aliphatics and the closed-chained aromatics.